Good, good evening, Guy-Vincent.
Good evening, Marcel. Okay, so welcome to this little video to talk about the midterm results of the midterm and go over the questions.
Yes, so we will go rapidly over each question, looking at where we think the main problems were. Maybe at the start would be a good idea to say that actually there are many people who did great on this.
Yes, a lot of good answers everywhere.
Yes.
In all the sections.
In all the sections, in all the questions, I think there were great answers.
Right.
However, we're going to be picky about...
We're not here to talk about the good questions.
Yes.
The good answers.
So we're here to talk about the elements of your solutions that we think really need to be corrected. Otherwise, you're going to have challenges in the workplace or in your next classes. So we're going to make sure we fix these. Right. And as well for the final.
For the final exam, very important. So just go over these things pretty quickly. We're not going to type any code this time and just look at the solutions and discuss about the kind of problems we have seen.
All right, so let's switch over to the actual questionnaire. So question number 1 is about the goods and services.
Right, goods and services. We have a book, we have a nuts basket, and we have taxes.
Yes, so there was a UML diagram that was meant to convey some information about the question. So certainly when you're looking at this diagram, it says that a book has some kind of relationship with goods and services, and the nuts basket also has a relationship.
That's right. The relationship is a dotted line. Goods and services is in italic. So all kinds of hints here.
Yes. The big hint was there as well. Can be seen as. Yeah. So in class we talked about 2 ways to relate the concepts. One of them is inheritance. So when we have concepts that are expressed using inheritance, we can say is a, so a student is a person.
Right. So in this case it would have been a book is a good and services, which doesn't sound quite right.
Yes. So really a service is not a good. A book is not a service.
Right.
So here everything was pointing towards the interface.
Right. It can be seen as a good and services.
And so here what it says is that all the goods and services have a get price. If you want to claim that you're a goods and services, you better have a get price method.
That's right. That's what it means to be a good and services.
Yes.
All right.
So were there any other challenges here? I think we got some questions regarding getters and setters.
Yes, many people were asking that, do we need to add or can we use getters and sometimes setters for books? And so I guess the answer was, well, if you are going to use it, you have to provide it.
Yeah, I think we were very consistent across sections. The answer was always, if you feel like you need them, well, you better implement them.
That's right.
But there were no marks for adding them, and there were no marks deducted if you didn't have them.
Because you didn't need them.
Because you did not need them, as you will see in the solution. This is something we talked about in the review session, that we try to encode or pass some information to you with these examples. So here you were expected to have constructors that would receive all these values. We're calling the method printLine of the object designated by B1. It's going to automatically call the toString, creating some nut basket object. So maybe we can turn over to the
let's have a look at the
solution.
All right, so we already said that goods and services was an interface. Really, there's not much to it. Public interface, the name, and then, well, you have the one method, get price, which is a double, and you do not have any implementation for it because
we should not see any variable there.
Nope.
We should not see an implementation. We could have seen public.
Yes.
Abstract, because this is an abstract method.
I knew you would code. Okay. so
that was it.
That is yes. So that was okay to do that. So we should probably mention that. So the expected answer was an interface, so public interface. A possible answer was an abstract class. And so if your answer was correct but was using an abstract class, you got some penalty, but not much. A concrete class was more questionable, of course, because then the get price implementation, well, the method could not be abstract. Then you had to do something in get price, and what are you going to do? There is absolutely nothing to do here. You don't. You need to have a price then, or you need to return some. I mean, it makes no sense.
Having said that, we were not very aggressive. Where if you had a abstract class, I believe, and everything was correct, you lost a mark.
Yes, 1 mark.
If it was a concrete class and the implementation made a lot of sense, would work, it was not the suggested solution, it was not the best solution, but still you would have lost a couple of marks.
Right.
So no big deal. So after that, you should probably jump to the implementation of the class book.
So yes, implements goods and services. Of course, if you have used an interface, if you have used a class, abstract or concrete, it extends.
Yeah, so we were looking for consistency. So if you have an interface, it's implements. If you have a superclass, that extends.
Right. Then we have our instance variables. They are private. They must be private, all of those. So it's not very difficult. If you have an instance variable, make it private and you're going to be fine. Constructor, as per the description. And not much to say here, I don't think.
No, so here the interface declares an abstract method called getPrice. So you need an implementation. Here really it's a simple implementation. It's actually a getter for the instance variable price.
That's right. Equals was a little bit more interesting. So you could see here that even though a book has a year, author, title and price, the equals method was only defined on author, title and year. So books that have same title, same author, published the same year at different price were the same. So it shows why an equals method is used. It's not simply a matter of comparing all your instance value of your instance variable values. Sometimes it's a bit more subtle than that.
Which reminds me as well that during the examination, a number of students asked me, is the equals method having 2 parameters, 1 parameter? So here, this is really where you go back to the sample code and it says, call the method equals of the object designated by B1, passing the reference of B2 as a parameter. So you have your answer there. And here as well, there's an example where B1 and B2 are 2 book objects. Clearly, they have they were published the same years, have the same author, the same book title, except that the price was different. Yet, when you're looking at the result of printing B1 equals B2, it's true. So the hint was there. It's important to read these snippets of code. They have a purpose.
All right. So things that went wrong here, I mean, mostly two things. Too many students use equal when comparing references. So, I mean, you can't do that. If you use equal, you are comparing the actual reference, so the address of the instance you are referencing, and that's not what you are interested in here.
No, so we would using equals would mean, and if we have it here, is other pointing at the same place, is author pointing at the same place as other.author.
Yes.
And that's really not the question we were interested in here. We wanted to know if these objects, who could be distinct objects, have the same content.
That's right. So it's a logical comparison, really.
Okay.
They mean the same thing. So that's the first error that we see. The second error that we see, and we are going to see that at a couple of other locations here, is you have to make sure every time you receive a reference that you are going to follow, you have to make sure that this reference exists. It's not null, because if it were null, which is very possible, then when you go other.author, it is going to crash.
Yeah. So other.author here would be generating a null pointer exception,
right,
if other was null. So
other author, other title, other year, every access to other dots will crash.
So it has to become a sort of something that's automatic. I'm about to look at the instance variable author of the object other, designated by other. There's a danger. I can get a null pointer exception. I put a guard here.
That's
I make sure I don't do that.
Yeah, it's not quite something for the exams. It's very important when you write code, and if you are going to access an object, well, do you have an object? You have to check that.
And it's especially important for the method equals, because here the last thing we would like to do is something like other equals null, then throw new null pointer exception. We really don't want to do this. The reason we don't want to do this is that the method equals has a well-defined contract. You're calling it, you pass a reference of another object, it's either equals or not. There's no reason for the method equals to crash. It simply tells you this is equals or not. You're passing null, it's not equals.
It's just not equal. Yeah.
All right, and then there was a toString, which simply returns a string representation for this object that consists of the name of the author, the price, the book, the title of this book.
Right. So.
Okay, I think we're good with that.
Yes. Then this one, so we added that, so we had more than one class that would implement goods and services. This is going to be interesting to illustrate what we wanted to do with text price just after. But while we were at it, so nuts basket, well, also implements goods and services, of course, so it will also have a get price. Now in this case we were trying to get to have a price that would not be a constant, or sorry, just a value. So we had something that was a function of the weight, and we had that. So here we had a price per gram, which we made a constant really. But you know, if you had hard coded, you know, 0.1 in your get price method, that was good. No problem with that. But I think that's it, right, for this one.
Yeah, I believe this one, the main challenge was that in the description of the question, we were not referring again to the method getPrice, and a number of students forgot to include it. But yet, in the question, it was clearly saying that the books and the nuts basket both are goods and services, and all the goods and services have a getPrice.
That's right.
So it was really pointing to the fact that all goods and services must have this method.
All right, and now all of that to reach this. So the class tax price. So really just a couple of things here that we were trying to achieve. The main thing that we were trying to achieve is to illustrate the fact that you would have the one method price tax included, which would be able to work with a book, with a nuts basket, and with basically anything that can be seen as a goods and services, because you can write the method with the parameter as a goods and services directly. So you have this one method, and you receive a reference to something that can be seen as a goods and services, and thus something that has a getPrice. And so now you can, in fact, implement price taxes included. And so it gives you a very nice, elegant, efficient implementation of this concept. And you don't have to have, as we have seen in some answers, several methods, one for books, one for nuts and basket, one for this and one for that. It's just everything is a goods and services.
Yeah, and in the questionnaire there were these dot.
Yes.
There, so we left it to you to decide what could be the type for the parameter province. So if you had a string and you were testing for this string, determining if you were in Quebec or Ontario, that was good enough. There were no solution was considered to be better than the other. The one that we have here is actually that province is of type double. It's already programmed, hard-coded to have the
right
number, the right number, the tax, and the correct multiplier, and that was it.
Yeah, all you have to do now is multiply that value by the getPrice, and then that's the answer.
All right.
So yes, and again, if we look at the PDF here, so we knew that these were class variables because we have to go to the right question here, but so we didn't say it was a class variable, but we showed it here. It's called directly from the class taxPrice.on.
Yeah, the context that's given is a class context. What's the prefix here is not the reference of an object. So clearly it was pointing at static.
Right.
That's good?
That's good. And so, well, this question was not bad, right? I mean, the average is rather high on this question. So overall, you did well there.
I think the average is probably somewhere around 80% for that question.
That's right.
So that was a really well done question.
Okay. Now, smoothing.
Smooth, yes. I think what surprised me the most of this question was the number of students asking me all sorts of questions during the exam. In particular, many students that I talked to, when they were reading this, did not see that the first part here, it says replace each value by the average of the value before, the value itself, and the value after. So every position I of the array was to be replaced by the average of 3 values. the one at I minus 1, the one at I, the one at I plus 1. So many students were proposing solutions with the average of only 2 positions. Of course, you can't do 3 positions when you're at the beginning of the array or when you're at the end.
That's right.
So there was this part of the sentence that was covering those cases. So when you're at the beginning, it's the average of 2, the first 2 values of the array. And when you're at the end, it's the average of 2 values, the ones at the end.
That's right. So, and we had several examples. And the examples were also showing special cases, like an array that has just one value, or a null array. So,
but if we take a step back and we go to the intent here,
yes,
this question was really about testing your ability to work with arrays, and was also making a link with the assignment 1, where in the assignment 1 for the linear regression, we were saying that some formula was calculated simultaneously.
Theta.
Yeah, the thetas
had to be updated
in parallel or simultaneously.
So you could not find a new value of theta 0 and update theta 0 and then try to find out what was the new value of theta 1, because at that point you had lost the initial value of theta 0, which you needed for the new value of theta 1. So you had to work with 2 versions of theta, the theta before and the theta after.
And here it's the very same thing.
Right.
As you're progressing through this array, you can't use an updated value from position I minus 1.
Right. If you have already replaced the value before by its average, then you cannot compute the average of the current value, because you need that value that was there before.
So that was calling for creating a second array.
Yeah, so temporary array in which you are going to, that you are going to use to solve that little problem.
Okay.
All right. So, oh yes, there was a print array question first. I guess that's it was just for you to get started with arrays.
I think unfortunately I saw many solutions where I would see just a system out print line of a. I've seen quite a number of solutions like that, and that would have printed just the type and followed with a bizarre number that's a unique ID for this particular object. So in Java, you cannot just print an array by doing a single statement like this.
So you have to go through the array. And you are going to go through the array, you are going to access, for example, here the length of the array and then the elements. And so if you do that, you are again following a reference. If you are following a reference, you want to make sure that you actually have something there and it's not null. So we insist that it is important to check before that whatever you received is not null.
In the solutions that I've seen as well, I've seen a number of students struggling making sure that there would not be a comma at the end, an unnecessary comma at the end. There's many possible solutions. The one that has been selected here is to stop early and to print the last element after the loop. Okay, so going to smooth.
All right.
So here again, if we're about to do things like a of 0, a of 1, we better have
A.
we better have an array. So a must not be null.
So in this case, there is something more, which is, well, you only smooth an array that has at least 2 elements.
Mm.
So if it has 1 or 0,
Yeah, this
because it
oddity.
is possible, then, well, there's nothing to do. But it's worse than that. There is nothing to do. But if you try to execute the code below on something whose length is, 0 or 1, you will, depending how you have written it, you will probably crash again. So
Yes, for sure, if the array was of size 0 and you're trying to access a of 1,
that is not
out of bound exception.
right.
So we said that we need to have 2 arrays to work with. There were many possibilities. So some students were working in a temp array and then at the end copying from temp to the original array.
Which is what we have here.
Or you could have copied everything to a temp array
And then
and doing your work, saving the solution back into the array designated by A. 2 correct solutions.
actually the other one would probably have prevented some of the issues that we have seen if you were doing that. So that, what do we do here? We create a temporary array. The size has to be the same as the size of A, and we do copy, we do move in the temporary array the right value, the correct value. So for the first value, we get the average of the first and the second value. Then, as we are inside the array, so from the second element to the element before the last, so those are all the elements for which you have both an element before and an element after. There's nothing to worry about. So just grab all these 3 elements and you get the average. And once you are done with that, then you do the same thing with the last element, which is the average of the last 2 elements of A. And then, so now in temp you have the answer. And you have to make sure that the answer is in A, not in temp at the end, otherwise it's lost. And what we have seen many times is A equal temp.
Yes.
At the end. Even though Marcel worked very hard
during the review session.
To try to give you, to remind you that this was not a good idea.
And actually, if this thing is still ambiguous in your head, on Piazza we had a poll that was done at the beginning of the semester.
Yeah.
It's called something test swap or
Yeah.
swap array. Search for the keyword swap on Piazza. The purpose of that example is to show what you would get if instead here you had the idea of doing A equals temp, tmp, the swap, and not having this thing here. The swap example is really explaining this. All right, so not a good idea to do this.
Great.
We're good?
I think we are good.
Okay. And then stacking. Yeah, stacking inspector.
So that was probably the question where we saw most struggle.
Yes, yes, I think so. I think with question 2, my take on question 2 is that it was simply not reading the question very well or having the special cases not done very well. Here, I think there were some fundamental problems with some or many solutions that we've seen.
Right.
Okay, so stack inspector is an object that receives the reference of some stack.
Right.
It has a method findLast that finds the occurrence of some object. It finds the index of that object in the stack, it finds actually the last occurrence, because there could be multiple instances of the object.
So
and it starts counting from top.
Right. So it will return the index where it was, and we were saying that it should return -1 if it's not finding the element, so it is possible to not find it. And of course, it should not destroy the stack while doing so.
Yeah, that was probably, that was one of the two main categories of errors that we've seen, I believe.
Right.
Okay, let's look.
Let's look.
Okay, so closing this, going to our stack inspector. So we had provided actually the signature of the class, the instance variable. The constructor was showing that we received a reference of some stack and we keep a reference to it.
Right.
So that later we can use that particular stack.
Okay, so here find last receives a target, and we need to find it in the stack, or we look for it in the stack. So now you are not stack here. You have a stack. You have a reference to stack. So you are outside using the stack. If you are outside using the stack, what you can do is push. You can do pop. You can do isEmpty, and that's it.
Yeah, I think that was our biggest disappointment, because the whole point about these abstract data types is that they're so easy to use. Here I have a stack. It could be empty or not. If it's not empty, I can pop something out of it. If it's not empty again, I can pop again, and I can do this as long as it's not empty. If I want to add something to the stack, it has a method push. So really just two methods to modify the content: push, pop, and a method to determine if it's empty. And in this case, we also provided a stack that had a peek method, but the peek is not necessary for this.
But so the point is, what we don't know and we don't need to know, and we really should not worry about, is how this stack is actually implemented.
No.
So in particular, everyone who started assuming that the stack was an array and was using that as the answer, well, you are missing something here. That it is important to realize that you don't know that. You don't need to know that, and this is not. This is not used. So you can't start going inside the stack and look inside for these targets that you are searching here. You have to use the method of the stack in order to achieve that.
We're always insisting that the implementation details are private. You never have access from outside, and really it turns out to be much more complicated to care about the implementation.
Right. Okay, so if you don't have that, if the only thing you can do is, push, pop, and pick, and you need to look inside the stack in order to implement that. You will have to remove these elements from the stack, and if you remove the element from the stack, then you have to do something in order to not lose.
We have to store the elements somewhere.
You have to store them somewhere.
We really have to go all the way to the bottom of the stack because we're looking at the last occurrence.
That's
so
right.
It could be, unless you've seen the element at the bottom, you don't know if you found the last. So we needed to remove all these elements from the stack.
Right. So it means you are going to need to remove a number of elements. You don't know that number ahead of time. You can't know.
Yeah.
So it rules out the idea of storing these elements in an array, because an array you have to know the size.
So what you know about this stack is it has isEmpty, peek, pop, push.
All right.
There's nothing there that says
Get
what's
length
the
or-
size, the
Yeah.
length, nothing. You can't. So I don't think we've seen many implementations where the students have created a fixed size array. I think that's one thing we were anticipating that some student would do.
Well, I mean, the students who were using an array were assuming the stack was an array, and were just using the stack as an array, basically.
Yeah.
So,
Here you need some data structure, some temporary, data structure to store the elements temporarily. You know that stack implementation exists.
yes, you have one right there.
There's one there. So the idea was to use an object of the class stack implementation to remove all of the elements of the current stack, push them into the temporary stack.
Right. So, when you take a stack and you remove the element one after the other, and you push them into a stack, into another stack, then you see that the element were in one order in the first stack, and you're going to take the top element and it's going to go to the bottom of the next stack, and then the new top is going to go just above the bottom, so on and so forth until this is empty. And so basically you have flipped over the element of the stack. So when at the end of this while loop here, what you have in temp are the elements that were in stack reversed.
So reverse would have been a good variable name there because it's a stack that contains the elements of the original stack in the reverse order.
Right.
There were probably two large families of implementation where you could have done your work of counting the position of that element as you were removing the elements from the original stack, or as we're doing here, we're going to be counting the index, or we're going to be counting the number of elements that there are on the top of the element that we're looking for as we are putting back the elements into the new stack.
So here, because we work backward, because the elements are swapped, reversed in temp, well, if the target is to be found, the last instance of that target in the initial stack is going to be the first instance of that target in the new in temp.
So here what this loop is saying is, as long as the temporary stack is not empty, keep going, because we need to take everything that is in the temporary stack and push it back into the original stack. So it goes from temp to stack. As we're doing this, result equals -1 means we haven't found what we were looking for.
Right. Initially it's -1, and
so as long as result equals -1, we have to look for this target. So if result is -1, we haven't found it. Let's go inside the if. If the top element is the value that we were looking for, here it was important again to use the equals. If it's what we're looking for, let's start counting. This is position 0.
We have found it.
It's
right there.
And then after that, every time we go into this while loop, result is not -1. We found what we were looking for. Let's just increment result. We're counting how many elements there were on the top of that instance. Okay, so
and that's it.
That was it. Okay.
All right. So that was this third question.
And the last one will be very short.
Yeah.
Yeah.
The only thing about the last one is, well, for one thing, again, read the question. Yeah, we are not asking you to evaluate this expression. So some students were trying to find the answer. But
Yeah.
it's not the question. The question is try to write the same expression in infix and do that using the algorithm we have seen in class.
Mm. So I've seen a number of students who were attempting to write code. That was not the purpose. We've seen a number of solutions where people were crunching the value of the expression, which is 2.
Yeah.
So we would, and you didn't get many marks for that. And here the correct answer was to give the corresponding expression in infix.
Using the algorithm seen in class.
And using.
Again, you know, this is important. Using the algorithm seen in class. So you have to show us that you are using the algorithm and you are not sort of guessing the answer here. We could give a very long expression so to make sure that you are not going to be able to guess it. And it's very tedious and it will take forever to do. So just make sure that you show that you use the algorithm, and the algorithm in particular will take every left-right operator of the postfix expression, and we rewrite it as open parentheses, left operator, right close parentheses, and so you need to have parentheses everywhere.
Yes. So in a nutshell, the algorithm reads the input. If it's a number, it goes onto a stack. If it's a number, it goes onto a stack. When it's reaching an operator, stop, take the operand from the stack, create the sub-expression. And the key here was really about this algorithm is that in the infix version, if we didn't include the parenthesis around, the order of the operations would not be preserved. So in order to preserve the right order for the evaluation of the sub-expression, we have to be very systematic. So here you could see by eye that, yeah, those parentheses around there are not needed, yet the algorithm does not know that. Likewise, here, the external
The outer ones
was needed.
Yes.
And even the very, very last one there. So some of you lost a 0.5 there for missing those extra parentheses.
That's right.
All right. And
That's
that was it.
That's it. So, yeah. So I guess that's the end of this thing, unless you want to add something.
No, I think that the next steps for you will be to have a look at your copy. If you have any question about the marking, about your solution, make sure that you understand very well the mistakes that you've made so that you don't make the same mistakes in the final.
That's right. And be ready. So the exam is available online. We'll put the link on Piazza. You know, you need to be ready for these kind of questions and even slightly tougher one moving forward.
All right. So good night.
Good night. Thank you.